Hello everyone. Today we are going to start simplifying rational expressions. So that's our first part of our goal stated. And then to also be able to state restrictions of a rational expression. So that fractions packet you were working with is supposed to be a nice reference so we can go back and review all the rules with fractions. But I'm going to have you, when you turn that in, it is going to count for a small grade. So what are rational expressions? They are fractions, but with polynomials in the numerator and denominator. So fractions that contain variables. So what are restrictions? Well, so far when you guys were going through that fractions packet, everything was just numbers. But a denominator cannot equal 0. So if we now have any variables in our denominator, that can't be allowed. So what are restrictions? These are values of the variable that cause the denominator to be 0. And if you recall, just say any number divided by 0 is undefined. It's not possible. You have to remember that. All right, so we're going to do a couple examples here. We're just going to focus on stating the restrictions for each expression, if there are any. So let's first take a look at the fraction 2/3. There are no variables here, so there are no restrictions. So no variables in the denominator specifically, so no restrictions. There is nothing that will make this fraction undefined. Let's take a look at x squared minus 4 over x plus 2. This is a typical example of a rational expression, and we're only focused on our denominator. So we would say, well, x plus 2, if that were equal to 0, what would x be? Just solving this, x would equal -2. So the restriction, we don't want this to happen, so the restriction is that x cannot equal -2. It could be any other number, so when we restrict, we say x cannot equal the number. All right, what if we just had 5 over x? That denominator could be any number but what? So we'll just say the restriction is that x cannot equal what number? Since it's just kind of standing alone by itself, it just can't be 0. All right, now if we had 4 over x squared minus 9, we don't want that x squared minus 9 to equal 0. So there's a couple ways to solve this. I'm just, based on what we've done in the last unit here, we're going to just add 9 to both sides, take the square root, so x would equal plus or minus 3. That's what would cause this to be 0, but then we would say our restriction is that x cannot equal plus or minus 3. Because if it did, we would get a 9 minus 9 in our denominator. So we restrict the value. It could be any other number except those two. All right, so now we're getting into both stating restrictions, if there are any, and also simplifying, which means just to put our fraction, our expression in lowest terms. So we're going to start with 2x squared minus 5x minus 3 all over x squared minus 8x plus 15. And guess what, guys? We have to recall how to factor. So I'm going to write these letters up here. FRC. So step 1 is to factor. I'm going to use a capital N for the numerator and capital D for the denominator completely. Step 2, for the R, we want to state restrictions. So we have factor, restrict. The C is for cross out common factors. So FRC, factor, restrict, cross out. So first we're going to factor the numerator. Notice there is no GCF, so we're going to make 2 sets of parentheses. I want you guys to see for a second what you think that could factor into. And pause the video to try that. Alright, so hopefully you were seeing that 2x squared factors into a 2x and an x. What's nice is we have a 3, so we either go 3 then 1 or 1 then 3. Our signs have to be different, so I'm just going to try this. I'm going to do 1 then 3, because I know I need to get a negative 5x in the middle. So on the outside, that's a 6x. If that were negative and then the 1 were positive, on the outside I would get a negative 6x. On the inside I get a plus 1x. There's my minus 5x in the middle. And then last, there's my negative 3. My denominator, there's no other way, there's no GCF to factor, so again I make 2 sets of parentheses. This one's a little more basic. The only way to factor x squared is x times x. 15 is going to be a 5 and a 3. Now my signs are the same because this last sign is positive, so 5 and 3, they're both the same, they're both negative. So there's step 1, I factored. State restrictions. So for this first factor, if x were a 5, I would get a 5 minus 5, which is 0. And 0 times this number would be 0. So I'm going to say x cannot equal a 5. Also right here, this x can't equal what? A 3, because if 3 minus 3 is 0, that whole denominator is 0. So there's my restrictions. Step 3 is to cross out common factors. So we have binomials up here. So if you notice, I've got an x minus 3 over an x minus 3. Those are common binomial factors, so I'm going to cross those out. So what does this simplify to? 2x plus 1 over x minus 5. How does this relate to the fractions packet we were just working with? Well, if I gave you a fraction like 2/10, we know that becomes a 1/5 because we divided out a common factor of 2 from each. So that's exactly what we were doing, only now we're not just looking at numbers, we're looking at polynomials. So let's try another one. Okay, here we have 2 minus n over n squared minus 4. Alright, step 1 is to factor. There's really nothing I can factor out of the numerator. So I'm going to leave that as 2 minus n. My denominator, if you guys remember back when we were factoring, this is a difference of squares. I have 2 terms, they're both perfect squares. So I'm going to make 2 sets of parentheses. Do n and n, 2 and 2, 1 plus, 1 minus. So I factored, that was step 1. Step 2 is to state restrictions. So we're going to say n cannot equal, of this first factor, so pretty much the opposite when we're looking at something like this. If n were a negative 2, our denominator would be 0. Over here, if n were a positive 2, so there's my 2 restrictions. If n were a positive 2, we would get a 0 here. So now I'm going to cross out common factors, but if you notice, I have something that's pretty close. This 2 minus n and n minus 2, they look similar, but they're kind of backwards. So I'm going to write it this way. 2 minus n, I'm going to rearrange this into a negative n plus 2. Then I'm going to factor out a negative. When I factor out the negative, I'm left with an n minus 2. So I'm going to write it this way. 2 minus n is equal to the opposite of n minus 2. So right now these two are opposites. So when I cross those out, what do we get when we divide opposites? Let's say if we have a negative 5 divided by 5, what will that give us? A negative 1. So when you divide opposites, you're left with a negative 1. So we could just put that negative 1 anywhere. So now my final answer I always like, if there's nothing else up top, I like to put it up top. We have a negative 1 over n plus 2. So whenever we see like a 2 minus n and an n minus 2, those are opposites. If we saw an n minus 3 and a 3 minus n, those would be opposites. And you could tell, look over here, the 2 is positive, over here the 2 is negative. Here the n is negative, here the n is positive. That's indicating we have opposites. All right, let's just try one more example. We have 2c plus 10 over c plus 5. So I want you guys to pause the video, factor anything you think can factor, try to state restrictions, and see if anything's going to cross out. All right, so pause the video if you need more time. Now the only thing we can factor out of the numerator is a common factor of 2. And then take a look at what's going to be left over. C plus 5, right? And I know that matches the bottom, but we have to wait. Step 2 is to always state restrictions. So this bottom C can't equal what? A negative 5. And then, this is technically also in parentheses, these are the common factors, so I just cross that out. And I'm left with 2. So we factor, we state our restrictions, we cross out common factors. That's everything that's involved with putting fractions in lowest terms. All right, so the worksheet I'm giving you today, just do 1 through 8 only. We'll do more problems on Monday. Let me know if you have any questions.